Alright, so here we have quiz 2. This is the second quiz review. Drawing a face card, Jack, Queen, or King, and drawing a red card from a full deck of playing cards are mutually exclusive events. So again, mutually exclusive events, these are things we want to know if they're disjoint or not. If they are disjoint, meaning that one cannot be both, then they're mutually exclusive. If one can be both, they're not disjoint and not mutually exclusive. So can we have something that's a Jack and also a red card? So event 1, Jack, Queen, or King. Event 2 is a red card. So we can have a Jack that is also a diamond, which is a red card. A Jack, which is a heart, also a red card. Queen of diamonds, Queen of hearts, King of diamonds, King of hearts. So there are 6 mutually exclusive, or there are 6 events in common here. So they're definitely not mutually exclusive. There's a lot in common here. So we're going to go ahead and select false and submit. There we go. Okay, what is the probability of if rolling 2 paired dice, getting a sum of 12? Okay, so we could have a 1 on the first dice, a 1 on the second, a 1 on the first, 2 on the second, etc. 1, 5, 1, 6, 2 on the first dice, 1, 2, 3, 4, 5, 6, etc., and labeling out our full sample space. So our full sample space would be filling out this chart. Again, this is equally likely, so we want the number of what we're interested in, number of sum to 12, over the total number. So how many ways can we get a sum of 12? The only way that can happen is if we roll a 6 and a 6. So we can only get that one way. Out of how many? Well, there are 6 here, 6 for this possible, and then there are 6 columns. So there are 6 by 6. There are 36 different combinations here of these 2 dice. So this is your total probability, 1 divided by 36, and we ask you to enter that as a decimal. So when you do 1 divided by 36, you come out with 0.0277, or 277. We're given that A and B are independent. And we want to know what is the probability of A and B. If these things are independent, then we know that the probability of A and B is equal to the probability of A times the probability of B. And so we fill these things in. This is 0.3 times 0.7. So we get 0.21 when we multiply these two together. So the probability of A and B is 0.21. We want to know the probability of A or B now, and given that A and B are independent. Remember, A or B is equal to the probability of A plus the probability of B minus the probability of A and B. On the lecture, we said that this was because we counted this area twice. So filling this in, this is 0.3 plus 0.7 minus 0.21, what we got in the last problem. So this comes up to be 1 minus 0.21, which is equal to 0.79. So the probability of A given B is just from this formula. Probability of A and B all divided by the probability of B. So what we have here is just the probability of A and B we're told is 0.1 divided by the probability of B we're told is 0.7. Once we do this division, we find that our answer is 0.1429. So we have this urn, and we're told that it has 5 red, 3 blue, and 2 orange. We just drew 1 blue. So now we no longer have 3 blue, we have 2 blue. What is the probability without replacement? This without replacement means that now we have 2 blue. That we draw, the next one is a blue. So how many blues do we have? There's just the number of blues that are left, the number that are total left in the urn. We can see that because it's random, it's equally likely we can do this. So the number of blues is 2. Out of the total, there's 2 orange. Now there's just 2 blue, so there are 4 here. And plus this 5 gives us 9. So we have 2 out of 9, which is 0.222 repeating. And that's our answer. Okay. Number 7. Drawing a face card and drawing an ace from a deck of full playing cards are mutually exclusive events. So we have a face card and drawing an ace from a full deck. Okay. So can something be a face card and an ace? So no, they cannot be, right? So because a face card cannot be an ace, yes, these things are mutually exclusive, so they are disjoint. Okay, number 7. Drawing a face card and drawing an ace from a deck of full playing cards are mutually exclusive events. So we have a face card and drawing an ace from a full deck. Okay, so can something be a face card and an ace? So no, they cannot be, right? So because a face card cannot be an ace, yes, these things are mutually exclusive, so they are disjoint.